This is exam physics 1101, exam 2 review on chapters 3 through 5. As far as what we're going to be doing. And the test, it will be approximately 18 multiple choice questions and about 6 short answer problems. All right, so I'll go through the topics for the test, and just, if you look at the lectures for 3, 4, and 5, you'll see, but I'll just briefly go over them as far as the exam. The exam, it'll open from October 3rd through the 7th. Check the exact dates on the exam calendar, and the quiz. You get one attempt, and I will score the short answer problems once everybody has completed the exam. Okay, so that's what we have there. All right. So, on chapter 3, first part is on vectors and scalars. All right, the difference between the two, what we mean by vector, we define a vector as having a magnitude, a length, and an angle defined relative to the x-axis. And for this part, we break it up into, I talked about it, so we got the x direction, y direction, the components of those. And you can use that PhET simulation program to work with some of these problems if you want. And again, we'll be doing vector addition, so adding two vectors by using the graphical method is by far the best way. A plus B gets you C, A plus B is C. As vectors are concerned, you can use a component method if you want, but for the purpose of this class, this will be sufficient. Okay. So check that again. Be doing projectile motion. All right, and I've gone through that. And the questions again will be related to either a projectile starting and landing on the same spot, where we have the range is given by V0 squared sine 2 theta over G, or we have it where it's launched at a certain height and given an initial speed, V0, how far does it fall, or if you know how far it falls, based on the combination, again, talking about that, either finding how far out it goes, given initial speed, or where it lands, how high it is. So those would be the two examples related to projectile motion as far as that's concerned. We're not going to do anything where you have the takeoff and landing are at different heights. That's more complicated than I want to get into here, and that is not the basis of the exam. All right, again, it's a parabolic curve, both cases. All right, I talked again about in the lecture some of those. And then finally, we have relative velocity. And that'll be given by, say, crossing a river. You're trying to go across, and again, I've gone through this. If the speed of a river is such that it has some speed V, and you want to cross at some, so V of river, and you're trying to cross V of boat. All right, what angle do you, if you just go straight across, what angle are you going to end up with? Or if you need to go, what angle to end up going straight across? Because again, if you go straight across, the river will take you downstream, and based on what we talked about before, the fact that if it goes this and this, then the tangent of the angle is actually given by velocity of the river over velocity of the boat. And from there you get a relative angle as far as that's concerned. Okay, and again, I went through some examples related to that. There's some in the book related to that as far as the end of the chapter. All right. All right, in one case, you go aim straight across, you get drifted downstream. The second case, you aim upstream, so you end up going right where you want to go across the river. Okay. So, again, keep in mind your sine, cosine, and tangent functions as far as that's concerned. And that's chapter 3. All right, chapter 4. What we have there, again, Newton's laws of motion. All right, first, second, which again, first law, motion of inertia. Second, F equals ma. And third, action, reaction force, and examples related to that. So the only one where we really have calculations is related to the second law of motion. And we go through the problems of that, definition of mass, what am I getting into here? So again, with the elevator, again, this relates to the Atwood lab. And elevator. So if you're accelerating up or down, what force do you actually feel on the elevator? And briefly on friction. So we also, those are the first parts. All right, we'll also get a little bit into friction. Okay, coefficient of static, coefficient of kinetic. Again, where this is always greater than that because this is what we call sliding friction. This is static friction. And once things start to slide, again, it's like pushing a box. It's hardest at first, but once it starts moving, it has kinetic friction and it starts sliding easier. And again, this goes from mu varies between 0 to 1. And examples related to that. And we're only going to be doing on horizontal scale. All right, so again, friction, what does friction mean? This is mg. Frictional force if you're pushing. So this is F weight. F friction is mu times friction of the weight of it. So we're pushing, the weight gives the friction, the problems related to that. All right. And then cases of the Atwood machine, either hanging over like this, 1 or M2, or we have something like this, where we have M1 is on a horizontal table, and we have here the forces are opposing each other here. Only M2 exerts a force on that. So M1, so the force and acceleration using, again, Newton's F equals ma is related to the applied force. Depends on these oppose each other. Here you only have M2 acting on, so this should be M2. So that's chapter 4. Again, there's nothing on inclines. There's nothing on inclines on the exam. Everything with friction related to a flat surface. Okay. All right, so that's chapter 4. Moving on to chapter 5 and the problems of chapter 5. That's circular motion. And talk about that. We have, again, acceleration, circular acceleration is v squared over r. So something traveling in a circle with some speed v, radius r, the centripetal acceleration is going to be given by v squared over r. And then the force, the centripetal force, which basically takes pulling, so you've got object of mass m will be m v squared over r. So that's the centripetal force as far as that's concerned. Now we talked about curves, highway curves a bit. And I'll just show the picture again. If you have a car trying to drive in a circle, the frictional force is given by mu mg. The centripetal force is given by mv squared over r. As you see, the mass has nothing to do with it as far as whether it can make it or not. And as long as the frictional force is greater than the centripetal force, the car will stay on the road. Otherwise, it'll slide off. If you have too much speed or too low friction, it will slide off the road. We have problems related to that. So that's in that case, we're not doing anything on banked curves, which again, in real situations, a bank makes it so you can go at a higher speed because you have a slightly downward force onto the inside. But we're not getting into that at all. And then finally, on chapter 5, Newton's law of gravity. And again, friction, force of gravity is m earth, m person, or whatever it is, times this constant g over r squared from the center of the earth. So this force of gravity depends on the mass of the earth, if we're talking about somebody staying on earth, the distance from the center of the earth to you, not from the surface. This is why force of gravity, like on the space shuttle or space station, is negligible because it's not much above the surface compared to the distance from the center itself. And the reason why it doesn't fall, doesn't hit the ground, because there's a centripetal speed that balances the centrifugal force. So this is what Newton found out. If you look at, again, when it's in circular motion, like that, then the centripetal force, mv squared over r, depending how fast it's going, equals the force of gravity, so it stays in a balanced circle. And we talked about the period for something near the Earth's surface, up at a geosynchronous at satellite, and then up at the moon. Right? What's the period related to each one of these cases? So when you have geosynchronous, and so on. So how does the period relate to that? And the facts of, again, we're talking about weightlessness of gravity and those things there related to Newton's law of gravity. All right, and a little bit of misconceptions there. Again, if you shoot something straight up, it's going to come straight back down. You have to give it that centripetal speed so it'll stay in orbit. So that's the exam, chapter 5 exam, and questions related to that. All right, so again, exam will be October 3rd, 7th. I will be around in class on, the exam starts on October 3rd. So I'll be in class on September 29th. I'm at 8 o'clock for anybody who has any questions. So again, I'll be in 2S208 at 8 a.m. on 9/29, or is it 9/28? $9.29, week from today, to answer any questions prior to the exam. So this will be on that time. So let me know if you have any questions. I can also meet some other times. So that's exam 2 for 2020.